Hello guys, so I am coming to you from the classroom today and you get to watch me demo lab for you guys. So what we're going to be moving into is we're going to be talking about preparing a standard solution, and the definition of what a standard solution is that it is a solution of known concentration made to a high degree of accuracy. So the glassware that we use to prepare this solution has to be extremely accurate, because we want to make sure that we're preparing a solution that is going to give us as little error as possible when we use it in a much larger lab setup, right? So we don't want our solution to be kind of half-hearted, so that at the end of a very large lab we end up with a lot of error, and it's all the result of this initial starting point. Now the important thing with this solution is that this is going to be assumed that you understand how to make the solution. It's one of those procedural things that you have to be able to do moving forward in chemistry. And generally on a lab procedure, the procedure will say prepare a solution, a 100 milliliter solution of 0.150 molar concentration for the lab. That'll be step one. And that's your instructions, because it's understood that you're going to know how to do that moving forward. So what you're going to do with this video today is I'm going to model the preparation of the solution. As I'm talking, feel free to pause the video, and you're going to be taking detailed step-by-step procedural notes. So you're going to number everything, step 1, step 2, and you're going to write very clearly and concisely, right? Not paragraphs. Concisely, you're going to write down what it is that somebody needs to do so that they can follow this procedure almost like a recipe would be written out to you. Okay? So a couple of material things that you're going to need. You can see I've got an electronic balance here. I have some distilled water, so you'll definitely need that. I have one of these plastic burettes. We have a volumetric flask, and these volumetric flasks, you'll note it says 100 milliliters. So this flask is specific to this particular volume. Okay. And these flasks can come in anything from super cute little baby flasks to massive, massive flasks, depending on how much solution you're going to make. You guys are going to work with this 100 milliliter flask. And you should be able to see here in the video, there's a very thin white line. That thin white line is the 100 milliliter marker. Okay, so you'll have one of these volumetric flasks. We use these specifically, not a graduated cylinder or a beaker. We use these specifically because they're of high accuracy. You're going to need probably a beaker, maybe two. So I've got two 100 milliliter beakers here. When everything is said and done, you're going to need a stopper, and you want to make sure that stopper is dry. And then two things I've got behind you guys right now. I've got a glass stir rod that you will use, and I've got a scupula. Okay, so that's your scupula. It kind of looks like a metal tongue depressor. So that's all of our materials. And then the final thing we need is our chemical, our solid. So we're making a solution from a solid. Now, step 1 is you need to figure out, knowing that we're going to make a solution that is 100 milliliters in volume. It's going to have a concentration of 0.150 moles per liter. And it's of this, let's see if you can see that, copper 2 sulfate pentahydrate. So what that copper 2 sulfate pentahydrate means is that you've got in this crystal, in this ionic crystal of copper 2 sulfate, there are 5 little water molecules sitting inside that crystal. And so when you calculate the molar mass for this particular substance, you're going to use the mass of 1 copper, 1 sulfur, 4 oxygens, and then you're going to add on the mass of 5 waters as well. Okay, so this is what you're going to be using. That step 1 is calculate what mass of this I need if I'm going to make a volume of 100 milliliters with a concentration of 0.150 moles per liter. Okay, so that's your step 1. Once I know, that's what I'm going to do. I'm going to take my beaker and I'm going to turn on my scale, I'll place my beaker on the scale, wait until the numbers have stopped flashing, and then I'm going to zero the scale. And what I'm doing by zeroing the scale is I'm subtracting the weight of the beaker off. So that now, whatever solid I put into this beaker is going to be the weight of just the solid. So we've calculated how much we want. I'm leaving that part up to you guys. And I'm going to place my solid into my beaker. And I'm weighing. I make sure I get exactly the amount I want. I need to be very careful that I don't overfill. Because if I overfill, what I'm going to have is I'm going to have a little waste container here on the side. And instead of, let's assume that's how much I want, and I went a little bit over, so I'm going to take a little bit out of my beaker. And now I'm just a little under, so I'm going to add a little. Perfect. I've got a tiny little bit left in my scoopula. Now I don't want to put that back into my container because this is my original solid. I don't want to contaminate it. So I'm going to put that into my waste container here on the side. Okay. Perfect. So we're all set. We've weighed out exactly the weight that we need. So I'm going to take this off of my scale and I'm going to move the scale out of the way. And I've got all of my solid in here. From here, what I'm going to do is I'm going to add about 30 to 40 milliliters of distilled water, so my pure water. I'm going to add that into my beaker. And it doesn't have to be super precise. The key is I don't want to add too much water because I don't want to accidentally overfill my solution. If I overfill my solution, I have to start again. So I've added around 20 milliliters. It doesn't have to be super accurate. And I'm going to take my stir rod and I'm going to stir this up until all of my solid is completely dissolved into the distilled water. Be patient. Some solutions, add just a little bit more. Some solutions you'll find dissolve quite readily. Other solutions, not so much. So I've got about 30 milliliters in there, and I've almost finished. I'm looking closely. Be very careful with the stirring process that you don't accidentally spill, because again, if you spill, all that care you took in weighing out your solid has gone out the window because you've just spilled some of that solid onto the lab bench and you can't recuperate it. Now, everything is completely dissolved in here. You probably can't see, but there's no crystals at the bottom here. Okay, so I know everything's dissolved in solution. So I'm done with the dissolving phase. Now here's the thing. With the stir rod, I don't want any drops of my solution on the stir rod because that's little drops that I originally weighed on my scale. So I want to make sure that any solute that's on the stir rod goes back into the solution. So I'm just going to rinse it with a very careful amount of distilled water. Don't go crazy. A little bit of distilled water, rinse it back into the container. Okay. Now my stir rod's clean. I'm going to set it aside. Now the only thing I did not grab, so you guys will have a funnel. You will have a plastic funnel. You must place the plastic funnel here. Okay, so I'm going to pretend I'm holding my plastic funnel here because I don't have it. Actually, you know what? I'm going to go look for it. So I'm going to pause you guys for a second.